Okay, so the next topic is about the Laplace transform. Hmm? In the last few lectures, we were discussing about the Fourier transform. Now we will switch to the Laplace transform. Now, before going to the basic definition of this Laplace, how we define the Laplace transform, I want to share with you some of the important things. Why Laplace transform? Why we need this Laplace transform, and how does it arise this Laplace transform? Now, first of all, the first point I will tell you about this Laplace transform is that this Laplace transform, the Laplace transform, I will write down the short form LT. The Laplace transform is actually an important mathematical tool, important mathematical tool which is required by engineers, physicists, mathematicians, and other scientists. Mathematicians and other scientists. So this is this Laplace transform is basically a tool, a mathematical tool, which is which has a vast application. Whether you will talk about in engineering, in physics, in mathematics, and in some other fields also. So this Laplace transform actually provides an easy method. The Laplace transform provides an easy and effective means, easy and effective means for the solution of means for the solution of many problems arising in various fields of science and engineering. Various fields of science and engineering. Right? Now, what basically this Laplace transform is? एक second. Call आ रही है. Okay. Now see, so far we were discussing about this Fourier transform. Now this Fourier transform is the Fourier transform and the Laplace transform are actually the same. So actually you see that we discussed in the Fourier transform that we are going from time domain to frequency domain. So I told you that if I have some signal, some function which is defined in some time domain t, and we just convert how which frequencies it contain. So we just obtain that by using the Fourier transform. Now this Laplace transform is actually the similar kind of thing, but there is a little difference. What is that difference? Let me write down the definition first. So this Laplace transform, we are also going from a time domain to a frequency domain. Let me write the definition first here. Then I will explain how we are actually going it from the one domain to the another domain. Now this Laplace transform is actually later on the problems in the Laplace transform are quite easy. You can easily solve any of the problems in Laplace transform, but try to understand the why actually we need this Laplace transform. Why does this arise? Why does we require this Laplace transform? Right. So this Laplace transform is actually a frequency domain approach. This is the definition: frequency domain approach for continuous time signals. Like this is a signal, this is a continuous time signal. That is, we can just, this is varying with the time. It is a continuous time signal for continuous time signals. Okay. Now it converts a function it Laplace transform. It converts a function of a positive real variable of positive real variable. For example, time मैं लूंगा, time t, which is a positive. You know that the time is always a real. It always takes a real values to a complex function, to a complex function of a complex variable of a complex variable of a complex variable. Let us suppose frequency, and we denote it by s. So what is the Laplace transform? This Laplace transform is the frequency domain approach for a continuous time signal. If I have the time varying signal, so we just apply this Laplace transform to convert it into some another function. Yani we are making it one particular function, changing it to another function using the Laplace transform. How we do that? That is actually some mathematical definition. Okay, now see, the time here is a real and the frequency s जो आपका है, it is a complex. Like for example, time is real, t is real, and the frequency s जो complex variable है, the frequency s, that is some a plus iota omega. Frequency a plus iota omega, it's a complex number. Yeah, so we are going from the real domain to a frequency domain. Frequency is a complex variable domain. Now another important thing about the Laplace transform is that it is useful in solving the linear. We will see, we will solve a linear ordinary differential equation. It is the very important application of this Fourier transform. It is useful in solving linear ordinary differential equations such as those which are encountered in the analysis of electronic circuits. Encountered in analysis of this electronic circuits. Because you know that when we talk about the time varying signals, we are actually doing with the electrical circuits or electronic circuits. So this is, so you know that we have seen in the last semester how the differential equation arise in, like for we have taken so many examples for the alternating currents, and so the differential equations which will arise there, we can solve those, we can find out the solution to those ordinary differential equations with certain initial conditions using this Laplace transform. It's quite easy. You will see the later part of this unit that how we solve those the second order differential equations. So these are some basic things about the Laplace transform. The first thing is that it's some mathematical tool which is required by the many people, like we have the engineering in physics and mathematics, right? So it actually an effective tool by which we can solve the various problems which arise in science and in many other fields like engineering. So this Laplace transform basically is a frequency domain approach for a continuous time signal. It converts a positive real variable time, and it converts one of the signal to, so like we have seen in the Fourier transform, we can go from a time domain to a frequency domain, and also sometimes we can go from a frequency domain to a time domain, that what we call as an inverse Fourier transform, right? One more important thing about this Laplace transform is they are useful in solving this linear ordinary differential equation which arise in electronic circuits and some other fields also. Now see, so one more important thing before going to the mathematical definition of this the Laplace transform. So I just want to share with you few things. अगर आपको याद होगा कि in Fourier transform, like for example in Fourier transform, मैंने so we represent some g omega जब हम कहते थे, the Fourier transform of some function f of t, so we represent it from some minus infinity to infinity e raised to power, sorry, some f of t e raised to power minus I omega t into dt. This is the Fourier transform of a function f of t. So we are going from the time domain to a frequency domain. So this is Fourier transform. Now how we define the Laplace transform? The Laplace transform is defined as some g of omega again, Hmm? This is just a comparison how it is different from the Fourier transform, but I will come to this definition later on, how we actually define it. So I will just define this mathematically, how we define this. I will come to that in a while. But before, I'm just trying to make you understand how this Laplace transform is different from a Fourier transform. So this G omega actually is, so here we are taking it from 0 to infinity. There are so many things which we can do about this Fourier transform. Actually, we can see how it actually arises. So this Fourier Laplace transform actually arises when we are taking a some power series. That is something else. So we are not going to into those that much details. So this G omega Laplace transform is defined as some function f of t e raised to power minus st into dt. Right now, here s is actually a complex. So as I said, s is equal to a plus I omega, जो मैंने अभी कहा था. So now if you use this, if you use this as a plus I omega, what will this become? Laplace transform. It is just 0 to infinity f of t. Now it will become e raised to power minus a t into e raised to power minus iota omega uh, I omega t into dt. Now, what is this e raised power I omega t? So you can see that this is 0 to infinity f of t e raised to power minus I omega t into e raised to power minus at into dt. Now see this part, e raised power minus I omega t. So this is actually a, so the Laplace transform f of t, Laplace transform of this f of t is the Fourier transform of actually f of this f of t into e raised power minus ft. So we can say that this is actually a Fourier transform of a Fourier transform of, what is this? This is an exponential function. I will just explain it graphically while. So you can say that this Laplace transform, so Laplace transform of this f of t is the Fourier transform of xt in, sorry, f of t into e raised power minus at. So this is, agar aap Fourier transform iska loge, that is, so we will just this is the function f of t e raised power at into I omega t into dt. So this Laplace transform is Fourier transform of f of t into e to power alpha t. What it actually means? So now we have, अगर आपको याद होगा जब मैंने Fourier transform आपको बताया था, we say that it actually, the in Fourier transform we, it tells us which frequencies are actually contained in are present in a given, or which sinusoid, which frequencies and sinusoids are present in a function. कितनी frequencies उसमें present है. Now what is actually happening in the Laplace transform? The Laplace transform tells us which sinusoids or and exponentials are present in, the function. What it actually means? So let me just write down this statement. This is important thing. So a Fourier transform tells us which frequencies and sinusoids are present in a function, whereas a Laplace transform tells us which sinusoids and exponentials, because we have the exponential here, exponentials, which sinusoids and exponentials are present in function, are present in a function. This is an important thing. Now what I mean by this sinusoids and this sinusoids and this the exponentials. Now how I can put these things into consideration? See, I will just try to explain, give you an idea about these things by अगर मेरे पास कोई spring है, if I am just अगर if I am tying a spring with a mass, some mass m, right? So if I put a mass on a spring, there are actually four things will happen in it. Now if there is no resistance at all, or air resistance or any other resistance, what will be the case? The first case is we will have the sinusoids, and I can have the sine wave or the cosine wave. So the we will have a wave like this, huh? So this is the first case. This is a sinusoidal case. If there is no air resistance. Now then there is an exponential decay. Exponential decay means if I place the same signal within some viscous field, or there is some drag, so like for example the velocity is going on decreasing, then in that case, the second case, there is an exponential decay. There's an exponential decay like this. So we called them as a, so that means the damping is present in that case. Now the third case is that अगर मैं स्प्रिंग टाई ये कर रहा हूँ, इसके साथ टाई कर रहा हूँ, then I just pull it, it will just oscillate back and forth, and as a result, after some time, it will slow down and it will come to rest. Well, in that case, what will be there? There will be both the sinusoids will be there, as well as the exponential, the damping will be present there. In that case, so sinusoids as well as the this like we have, it will go like this. यानी ये इस तरह से होगा, it will go on like this. यानी we have the sinusoid as well, it will go on decreasing the exponentially. There is an exponential decay. So well, in that case, for such kind of a signal, so here, so this is an sinusoidal, this is an exponential decay, exponential, and here it is sinusoidal plus exponential. तो यही चीज मैं आपसे यहाँ पे कह रहा था कि अगर हम Fourier transform में क्या है, we were for example talking about this kind of a signal, so we see that the which frequencies are actually contained in the given signal. Now when the second case is exponential, it's not true for this, but sometimes we can have this case, like we have the sinusoids and we have the sinusoids present in a given wave function, given this function, as well as it will go on decreasing exponentially. So well, in that case, we will just use the Laplace transform to find out the which sinusoids and the exponentials are actually present in that given function. Then there is another case that is a different case other than these things. There is a final case. We are not interested in that particular case. So this is actually the graphical representation, what I mean by how we can, why we have the use of this Laplace transform. For example, we have the damper sine wave. अगर आप damper sine wave की बात करोगे, so damper sine wave is like this, ना, मतलब इस तरह से, यानी it will go on decreasing like this. Is what we call as a damper sine wave. So for the damper sine wave, it's like e to power minus at into sine of omega t. So this is this wave. So for this, so it contains the sinusoids as well as the exponentials. So we need the Laplace transform for such kind of a function to change it from a one domain to another domain. This is just an introductory part about the Laplace transform. Now I will go to the mathematical definition of this Laplace transform. Then we will see how we can apply that particular mathematical formula to obtain the Laplace transform of any kind of an thing which we have, right? Is it okay? Do you understand? I hope you have noted down. This is very important. You cannot find it from any book. This is just an out of the books. The books में जब आप कहीं भी चाहे आरएफकिन पे जाओ या कोई और बुक आप लोग जाओ, तो वहां पे सिंपली आपको ये डेफिनेशन जो हम अब पढ़ेंगे यहाँ से स्टार्ट है. The things which I told you about the Laplace transform, how does it arise, why does it come from, so it's not mentioned over there. अगर आप कोई भी बुक खोलोगे, you will see from this particular definition. Now see the Laplace transform. Laplace transform. Now I will consider a function. Consider a function f of t. Mathematical definition. अब हम इस पे आएंगे. So this function t is defined for all t taking the values greater than or equal to 0. Yani it has the positive values only. Right? Now, if I multiply this f of t by some exponential and integrate with respect to t from 0 to infinity, right? Then if the resulting integral exists, then that is existing kya matlab hai resulting integral? That means this integral has some finite value. Then it is a function of some other variable that we call as an s. I will not write these things, but I will just simply write it. Yani, if I multiply this f of t and integrate it from 0 to infinity, e raised to power minus st, right? F of t into dt. So वही चीज मैं कह रहा था, if I multiply this f of t by this exponential e raised power st and then integrate it from 0 to infinity, अगर ये resulting integral, जो ये integral यहाँ पे आया है, if it exists, यानी this will have some finite value, then it is a this integral will become a function of some other variable जिसको हम function of s बोलते हैं, and usually we denote it by f of s, capital F of s. This is a function, then we are converting it one particular function to another function, and this thing is what we call as an Laplace. So this is a symbol which is used to this Laplace transform of f of t. Either we denote it by Laplace transform of f of t or f of s. So it is defined as an f of t multiplied by e raised power st, f of t into dt, right? So this is the mathematical definition how we actually define the Laplace transform of any function. Now this L is an operator. This is what we call as a Laplace transform operator. This is Laplace transform operator, right? और ये function f of s जो है, जो is called the Laplace transform of function f of t. This is called Laplace transform of function f of t. So this is actually the Laplace transform function, right? Laplace transform of a function f of t. Also, about this operator, this is a linear operator. What I mean by the linear operator, that means if I operate it on two different functions, like for example, I have a1 and not a f1 of t plus b f2 of t, right? So it is always equal to the Laplace transform of some constant. If I take the constant of Laplace transform of f1 of t plus b Laplace transform of f2 of t. So here I am taking only the two. Yeah, I can take n number of the functions. So this is also one property of this Laplace transform, that it is a linear operator. Now जो original function यहाँ पे है, जो original function f of t है, so this is called the inverse Laplace transform of. So we will see how we will obtain this inverse Laplace transform of the function f of t is called the inverse Laplace transform. Inverse Laplace transform of f of s, right? And is denoted and is given by and is given by, that means this f of t is always given by this Laplace inverse transform of f of s. So we have to do some exercise on this, how we can find out the Laplace transform on this. So this is the mathematical definition, that is we multiply the function. Now you just remember here that this s is actually a complex variable, huh? It's the complex variable. So this original function actually contains the sinusoids as well as the contains the sinusoids as well as the exponentials, huh? Okay, let us try to find out how we can find out the Laplace transform of few things. I will just start with a very simple kind of an example. So for example, find the Laplace transform of some constant value 1. Find the Laplace transform of a function f of t which is equal to some constant value 1. I have to find out the Laplace transform. Now since you know that, अभी मैंने कहा the Laplace transform of function f of t, which we denote by this f of s, is given by integral 0 to infinity f of t, right, e raised power minus st into dt. Now what is my f of t? Now f of t here is 1. So what will be the Laplace transform? So you will see that the Laplace transform of this Laplace transform of 1, I will write simply Laplace transform of 1, will now become integral 0 to infinity 1 into e raised power st. It is simply minus st into dt. Now you can integrate it. So it is e raised power minus st divided by minus s, right, from the limits 0 to infinity. Now when you will apply the infinity, this will become indefinite, infinity by infinity, that is not defined. But when I take it in minus and minus will become plus, e raised power anything that will become this 0, that will become 1. So it will be 1 by s. So the Laplace transform of 1 is equal to 1 by s, right? So we can obtain corresponding. I can just change it from a time domain. For example, अगर ये time domain में है, I can take the different values of corresponding different values of t. I can find out the different values of s. And s, you know that s is given by some a plus I omega, frequency. I can just change it from a time domain to a frequency domain. So it's given by the 1 by s. And remember that s should be a positive here for s greater than 0, right? Similarly, let us take one more example. Now you can find out the Laplace transform any kind of a function. Only thing is that now we have the one, the function, this the value of the function will be different. For example, I will ask you to find the Laplace transform of a function. Find Laplace transform of function f of t is equal to e raised to power at, right? So where this t is always positive, it's either greater or equal to 0, and a is a constant. A is a constant, right? Now again, the Laplace transform of e raised to power at will now be equal to integral 0 to infinity e raised to power at f of t e raised to power minus st into dt. Again, now what we will do, so you will see that it's integral 0 to infinity e raised to power a minus s into t into dt, right? Now we have to take the derivative with respect to t. So you will say that this is e raised to power a minus s into t divided by a minus s from the limits 0 to infinity. Again, for 0, hmm, for e raised to power minus s minus a minus s minus a. Okay, I will take it in later on s minus a. So now for infinity, it is not defined. So this is gone. And for the 0, it will be minus e raised to power e raised to power 0, that is 1. It's simply t jab 0 hoga, it will be e to the power 0 divided by a minus s. Or you can say that this is 1 divided by s minus a, right? So the Laplace transform, this is equal to Laplace transform e raised to power at, right? आसान है ना? Okay. Now again, if I'm taking the cos hyperbolic function, find the Laplace transform of f of t is equal to f of t is equal to cos hyperbolic at, right? We have to find out the Laplace transform. इसका क्या होगा? Now first what I will do, I will say that since you know that the cos hyperbolic at is always equal to e raised to power at plus e raised to power minus at divided by 2, isn't it? You know it from the very beginning. So the Laplace transform of this cos hyperbolic at will now be equal to the Laplace transform of e raised to power at e raised to power at plus e raised to power minus at divided by 2. Now, I was saying that Laplace transform is a linear operator. So you will say that I can take the 1 by 2. It is the Laplace transform of e raised to power at, right? 1 by 2 and plus Laplace transform of e raised to power minus at. Now you do not need to do it all the time. What is the Laplace transform of e raised to power at? अभी मैंने किया था इसको. So it is 1 divided by 2 and it's 1 divided by s minus a plus what is this? It will become 1 divided by s plus a. ठीक है? अभी इससे पहले वाले एग्जांपल में किया था. So this is 1 divided by s plus a. On further simplification, you will say that this is s plus a, s minus a, minus a minus a. So it is twice s. 2 and 2 will get cancelled. It will be s divided by s square minus a square. Right? So this is the Laplace transform of cos hyperbolic at. Now similarly, you can find out the Laplace transform of sine hyperbolic at, right? This is an assignment for you. Okay, fine. Okay. Now, one more thing. Find the Laplace transform of Laplace transform of sine of at, for example. Laplace transform of sine of at. Now sin at है, इसको हम कैसे डिफाइन करेंगे sin at को? You know that the sin of at, और sin of at के at कैसे देंगे? It's given as e raised to power iat minus e raised to power minus iat divided by 2 iota, isn't it? Right? Or you can write down this as, so the Laplace transform of this sine of at will be the Laplace transform of this thing, right? I will write down this 1 by 2 iota यहाँ पे लिख लूंगा जैसे मैंने अभी किया था. So then it will be the Laplace transform of e raised to power iat minus e raised to power minus iat, right? So that means that we have the Laplace transform of this and Laplace transform of this. Okay. So what is the Laplace transform of this? Laplace transform of this. Okay, let me just first write it. So this is 1 by 2 iota, and then I will keep it in this kind of parenthesis. This is the Laplace transform of e raised to power iat, okay, minus Laplace transform of e raised to power minus iat. इसके बराबर हो गए. Now this is the function. Now this is function. So you will say that this is 1 by 2 iota. The Laplace transform of eiat will be now integral 0 to infinity e raised to power minus st into e raised to power iat into dt. Similarly, minus integral 0 to infinity e raised to power minus st into e raised to power minus iat into dt. Now what you need to do is to solve these integrals. What is this integral, by the way? It will be s minus a. अभी हमने इसको solve किया है. So what is this integral equal to? This will be 1 by 2 iota, 1 by 2 iota, 1 divided by s minus iota a plus minus 1 divided by s plus iota a. You do not need to solve it again and again everything, because we have done it just a while ago. Now solving these two, so not solving, so you just simplify it a better. It will be 1 by 2 iota, then this is s plus iota a minus s plus iota a divided by s square minus a square, sorry, plus iota, minus into minus will become plus, and iota square is minus, it will become plus, s square plus a square, right? So now this will be s and s will go on, it will be 2ia divided by into 1 by 2 divided by s square plus a square. This 2 and 2 is gone, and 2 iota यहाँ पे है, rather 2 iota. So this 2 iota and 2 iota is gone, it will be a divided by s square plus a square. Now similarly, you can find out the Laplace transform, the Laplace transform of cos of at. Cos of at. By the way, this should be equal to s divided by s square plus a square. You have to find out this. इसका find करना है, इसका ये आएगा Laplace transform. Now one important thing, one more important thing which is mostly used while doing this Laplace transform of some other complicated functions, that is the Laplace transform of a function t raised to power n. So another one, and it's very important, the Laplace transform f of t is equal to t raised to power n. We have to find out the Laplace transform of this, where n can take the values like 0, 1, 2, so on. So what is Laplace transform of t raised to power n then? So the Laplace transform of t raised to power n will now be equal to, as per the definition, 0 to infinity e raised to power minus st into t raised to power n into dt. Isn't it very simple? Right? See, what I will do, just to simplify it, I will say that suppose this e raised to power minus st. By the way, we have to prove that this Laplace transform of t raised to power n, Laplace transform of t raised to power n is equal to n factorial divided by s raised to power n plus 1. ये हमें find करना है. Okay. Now see, what I will do here, I will say that let's suppose put st is equal to some other variable x, or what will be t now? T will be equal to then x by s, right? Taking the derivative, or I can say that this dt will be equal to dx by s, 1 by s into dx by dt. That is taking the derivative with respect to t. It is 1, it will be dx by dt. So okay, then what will this integral now become, making this substitution? So you will say that this will be integral 0 to infinity e raised to power minus st, that is e raised to power minus x. Then t, what is t? T is x by s raised to power n into dt. Dt is dx by s, right? Now s is constant, we have the derivative with respect to x here. So what I will do, you will say that s में बाहर ले लूंगा, यहाँ पे n है, यहाँ पे 1 है, so it will be 1 divided by s raised to power n plus 1 integral 0 to infinity e raised to power minus x into x raised to power n into dx, right? ओके, नाउ यहाँ पे गामा फंक्शन एक्चुअली रोल प्ले करती है, वो मैंने आपको थोड़ा सा आइडिया दिया था सेकंड आपके लास्ट सेमेस्टर में जब आप पढ़ रहे थे. नाउ यू वी नो दैट गामा फंक्शन, अगर आपको याद होगा मैंने आपसे कहा था गामा ऑफ n plus 1 गामा फंक्शन इज ऑलवेज डिफाइंड एज 0 to infinity